As living organisms, it is required for human beings to consume nutrients in order to survive. Currently, chemical additives and preservatives are used in much of our everyday foods, and thus it is important for one to better understand preservatives. With the rise of greater agricultural techniques and technology, humans became able to produce more food than needed to be consumed. Thus, the idea of storage was implemented. Many foods, however, have short lifespans and spoil easily. Given this problem, humans dating back in the Tang Dynasty in China found ways to lengthen the lifespan of foods. First, salting and freezing was used to better preserve foods. But as time passed, greater loads of food were needed to be transported for months from Asia to Europe. During 900 AD, people have used other natural preservatives such as spices. Further down the timeline, as industrialization and globalization expanded, the food trade thrived. Given this situation, man-made chemical additives were produced to better preserve the life of foods for transportation across lands and seas. Preservatives thus play an extremely important role in the storage of foods, as it does in today's society.
The purpose of our lab was to determine how the amount of preservative affects the decay and color change of foods. Our independent variables was the amount of preservative added to the food. Our dependent variable was the speed of a color change. Our controlled variables include the type of fruit, the environment we did our experiment, like their test location, and the type of preservative we added. The hypothesis for our experiment was, if more preservatives are added to the fruits, then color change of fruits will be slower, because preservatives help delay decay and stuns the rate at which the fruit will change colors. We predicted that there would be an exponential increase when graphed with time on the x-axis and color change on the y-axis.
The equipment that we used was potassium acetate, made from acetic acid and potassium hydroxide. We also used 3 red apples, 3 green apples, 1 color chart, 1 knife, 1 timer, 1 balance, 4 beakers, 1 graduated cylinder, 1 stirring rod, 24 small label stickers, 1 hot plate, 2 thin metal scoops, and 2 pieces of small scratch paper. Procedure. First, acetic acid was prepared in a graduated cylinder along with some potassium hydroxide with a balance. The two were mixed together to form potassium acetate and was placed in a 1-liter beaker. Potassium acetate is the only chemical additive that will be used in the experiment. Then, the beaker was placed in a fume hood and a watch glass was placed on top. It was then heated to boil off the water that was formed by the reaction on a hot plate until all the water was removed. Then, 2 green apples were cut into a total of 8 slices. 0.5 grams of potassium acetate was spread evenly with a thin metal scoop on 2 slices. 1 gram of potassium acetate was spread evenly with a thin metal scoop on 2 slices. 1.5 grams of potassium acetate was then spread evenly with a thin metal scoop on another 2 slices. 2 other red apple slices were left as controls. All slices were placed next to a window for 5 days. This ensured that all slices were in an identical environment. Each slice was labeled with a label sticker. Color change and observations were recorded at 10-minute intervals for the first hour. Color change and observations were then recorded after school every day for 5 days. The color of the fruit was compared to the color chart. The same steps were repeated for 2 different red apples simultaneously.
Our experiment was based around the decay of apples. And one way to determine this would be observe the color change of the apple. So to make the color chart, we cut a slice of apple and took pictures periodically over the course of a week. We then selected several pictures that showed a distinct color change and labeled them in order, with 1 being the original color and 8 being rotten. The data we collected did support our theory that preservatives would slow down decay and color change. Our predictions were correct as seen in the graphs, where the apple slices covered in potassium acetate uniformly had a slower rate of decay than the apple slices not covered with potassium acetate. In all of our graphs, the data for our control experiments was a lot steeper than our other experiments, meaning that the rate of decay was much faster in the ones without any potassium acetate. All of our control apple slices started at 1 on the color chart and ended up in the 7 to 8 range by day 5, while the apple slices with preservatives mostly started at 2 to 3 range on the color chart and ended up in the 5 to 6 range, meaning that our control apple slices decayed at a faster rate than the apple slices with preservatives added. This shows that the apple slices with preservative added to them go through some color change before the control apple slices, but does not decay as rapidly over the course of the experiment.
In this experiment, it was proved that food decays at an exponential rate and that the more preservatives used, the slower the rate of decay for the food.